Hi, I am Anindam Mullik and you all are welcome to my channel Technical Ori. Now, our today's topic is heap sort and then we are discussing on the Heapify. Okay, so you know that there is a sorting method which is called heap sort. How these heap sort are working, we are discussing in this video. And after the completion of the heap sort, we are discussing on the what is Heapify, how the Heapify methods are work. Let's start. Now, first is heap sort. Okay. Now, as the name says, heap sort, that means this is a nothing but a sorting method, but we are using the concept of the heap tree, heap data structure. Now, what there is a two process, that means two step in the heap sort. First of all, we are creating a heap. That means first of all there is a process of creation of a heap tree. Then delete the all elements of the heap one by one, and at last we found that the all elements are be the sorted order. Again I repeat, there is a two step in heap sort. First is creation of the heap tree. Next step, delete the all elements on the heap one by one. The elements will be sorted. Now for an example, this is the unsorted array. Okay, this is the unsorted array. What is the elements? 10, 20, 15, 30, 40. Now our target is we are sorting this array elements by using the heap sort, or we can say by using the process of the heap sort or creating the heap concept, heap data structure. Now we assume that the first element is on the heap tree. Yes. Now it is a heap already in the heap. We are assumed that. Now I have a question. There is only one node is there in the heap. Now I have a question. Is this a max heap or min heap? Both is possible. It is maybe there is only one element, right? Only one node in the heap. Maybe it is a max heap or maybe it is a min heap. But yes, definitely it is a heap. Now, if you represent with an array, it is only one element are there. Now, next element. Now we insert the next element. What is the next element? 20. Now, so obviously, as we know that in the heap, all elements are inserted on the level by level. That means level balanced. Heap is a level balanced. Level by level, all elements are inserted. So obviously 20 is or go to the next level. That means left child of the 20. So we are inserted. Now, is this a now here we are create a max heap basically. Now, is this is a max heap? Which first of all we check what is the concept, what is the property of the max heap. Every time root is greater than, that means parent is greater than this child nodes or equal to. But if you are here you are compared, we check, if you are check here root is smaller than this child, that means 10 is smaller than the 20. Now what is the procedure? What do we do now? Adjust the elements. That means we are swap with the 20 and 10. Then after swapping, the heap become max heap become this 20 is goes here and 10 is go there. So 20 is on the root, 10 is become the left child. If you represent the tree on the array become 10 then 20. Next, what is the next element? 15. Now we insert the 15. What the 15 the inserted? Obviously level by level fill up. So obviously 15 is goes here. That means the right child of 20. Now again, now it means every time you check if the max heap property are stored or not. Here if you check, yes, 20 is greater than 10 and 15 both. That means root is the greater than its child. Yes, it is already in the max heap. So just we are represent in this tree on this array 20, 10, 15. Now again insert the next element, that is 30. Insert the next element, that is 30. So what the 30 is inserted, this level is filled, this level is filled. Yes. So go to the third level. So 30 is inserted on the left child of the 10. Now again we check, is this is the max heap? How can you compare? Just compare with the 30 and that means the root and its child. Here if you are compare, what do we found? Violate the max heap property. Why? Because the root is smaller than the child. Violate the max heap property. Now what do we do? Adjust the elements. That means swap the child and root. Swap the this. That means 30 goes here, 10 is go there. So swap up. Now after swapping, the tree become this 20 is here, 30 goes here, 15 is go there, and 10 is become the left child of 30. Now again we check, is this is a max heap? If you check, no, 30 is greater than 20. No, it is not a max heap. Again we exchange. That means we are adjust the elements. Exchanging between the 30 and 20. That means we have swap. 30 goes here, 20 go there. Now after swapping, the tree become this. 30 go to the root, 20 become the left child, 15 become the right child, and 10 is become the left child of 20. If you represent to the array become this 30, then 20, 15, 10. Just level by level traversal, level order traversal. Now insert the next element. What is the next element? 40. 30 were inserted. Now next element is 40. We will insert the 40 on this max heap. Now where the 40 is inserted, obviously every time the heap we are filling with the level by level. That means yes, this level is full, this level is full. Yes, this is the one element. So now obviously 40 goes here. So 40 is inserted on the right child of the 20. Now again we check, is this is a max heap? Is this is a max heap? Check first of all we check. Yes, if you are working like no, this is a violate the max heap property. Why? Here root is smallest, root is smaller than its child. Violate the property. What is the max heap says? Max heap property says that every time root parent is greater than its child, but here it violated. So what is the procedure? Adjust the elements. Exchange between the 40 and 20. 40 goes here, 20 go there. So after swapping, the tree become this 30, then 40 is a left child, 15 is the right child, and 10 is the left child of 40, 20 is the right child of 40. Now again we check, it is a max heap or not. Now we check. If you are compared on the 30 with this left child, right child, now we found no, it is a violated the property of the max heap. How? 30 is smaller than is a 40. That means child is greater than root. Violate the proxy property. Now what do we do? Again adjust the elements. Exchange the 40 and 30. 40 goes here, 30 go there. So after swapping, the tree become max heap become this. 40 goes here, 30 go to the right child of 40. For 15 be the right. Sorry, 30 be the left child of 40. 15 be the right child of 40. 10 is become the left child of 30, 20 is become the right child of 30. Is this is a max heap? We check. Parent, what is the parent node here? Or root? 40. 40 is greater than 30 and 15 both. Yes. Now 30 is greater than 10 and 20 both. Yes. Now and 40 is become the maximum element of this tree, which is on the root. What this is a max heap property. Max heap property also says that every time we maintain the max heap property, that means parent is must be greater than his child or equal to his child, and every time maximum element be the root. Yes, this is the successfully satisfying this tree. So yes, this is our final max heap. So if you represent with the array, this is the representation 40, 30, 40, then 30, then 15, then 10, 20. Yes. So our first step is over. What is the next step? Delete the all elements one by one. Then the elements will be sorted. Now we have delete the all elements one by one. How can I delete them? How can I delete a node? We know already in my previous video I am discussing how to delete a node. Okay, how can I deletion in heap? Already I have discussed on my previous video. I recommend you please please visit my previous video for better understanding. Now go forward. So this is our tree. This is our max heap. Now which element we have deleted? Every time we delete the maximum element, that means root. Here we are taking the max heap, or if you take the min heap also, we are taking the minimum element. So here we take the max heap, that means delete the root. So delete the root. Now which element is go to the place of root? Every time the last element of the array, or the last element of the complete binary tree, or last level element of the complete binary tree, that is 20. So 20 is goes to the here, 20 is go here, so 20 is go here. Now just here we are writing the 40 here, for it is not a part of heap. Now check, is this is a max heap? No, because root is smaller than its child, that means 30 is greater than 20. Violate the property of max heap. Now what is the procedure? We know that already I have discussed the procedure of deletion. Same way we are done here. Okay. What is the process? Rule says that compare with the children's of the root. Now we are comparing. Now check which is greater, 30 or 15. Which is greater? 30 is greater. Swap with the root to that child. So we are swapping the 30 and 20. That means greater value with to root. We are swapping. So swap 30 and 20. So after swapping, 30 is goes here, 20 is go there. Now this is the representation. Now if you are observed, there is a free place. That means your element are deleted. That's why there is a free space. Now what is the procedure? Just this element, that means this tree, we are just repeat this tree. Okay. Now so after that means after deletion we are getting this tree, just this tree. Okay. Now so there is a free space, just we are put this 40 on this free space. This 40 is not a part of heap, we just put here. This is a, like, for that reason I have done the partition here. This is a partition after the index number 4. This 40 is on the not a part of heap, we just keep it here. Okay. Now next again we repeat the procedure of the deletion. Now again delete the root, delete the maximum element, that is root, delete the 30. Now which element is go to the root? Last element of the complete binary tree, or last element of the array. What is the last element here? 10. This is not a part of heap. This up to this is a part of heap. What is the last element? 10. 10 is goes here on the root. 10 is goes here. Again check, and we are just write here 30. This is not a part of heap. Just we are kept it here 30. Okay, just write here. Now again we check, is this is a max heap? No, it is not a max heap. Because why? Root is smallest than the all is child. So it's not a max heap. How can I make a max heap? What is the rule? Again we compare with the child of the root. Two child of the root. Here compare 20 and 15. Which is greater? 20 is greater. Swap with the greater child of the with the root. That means 20 is goes here, 10 is go there. 20 is goes here, 10 is go there. Again. Now if you are observed here, after deletion of the 30, there is a two free space. Now so 20 is come here. Now so the array become 20, then 10, then 15. Now there is a two free space. Now 40 is already we are put is here in this free space. This is the partition. Okay. After the partition means this right hand side, this is not a part of heap. So 40 is already there. Now there is another free space. So we have just put this 30 here. Just put this 30. This 30 and 40 is not a part of heap. That's why we are represented with this partition. So now again repeat the procedure. Again delete the root. Which element will go to the in place of root? Obviously it is the last element of the array. That means which element? What is the last element of this array? 15. That means this is not a part of heap. Up to this, that means 20, 10, 15 is the 1, 2, 3 index. It is a part of heap. So what is the last element? 15. 15 is goes the root. Now just we are here write after delete the 20, we just write here the 20. It's not a part of heap. Okay. Now, again we check, is this is a max heap? Yes, this is a max heap. Because root is greater than its child. Yes, this is a max heap. So no need to swap. No need to swap. So now, there is a 3 free spaces. Now here just we already have this is a part, that means this is a partition. On the right side of this partition, is not a part of heap. Up to the left part of this partition is a part of heap. Okay, that means you have the only 2 elements, 15 and 10. Now on this free space we are just put on the 20 here. So 20, 30, 40 is the not a part of heap, but here just we have put the elements 20, 30, 40 which are deleted already. So that means you keep in mind, on the right part of this partition is not a part of heap. Only the left part is on the part of heap. Now again repeat the procedure. Delete the root. Delete the 15. Which elements are go to there? Only we have a one element. 10. 10 is goes here. Just 15 here. We are right 15 here. Just right. Now. So there is a 4 free space. There is a partition. Okay. Only one elements we have. Now if you are check, is this is a max heap? Yes, this is a max heap. Only one element, but it's still it is a max heap. We can say it is a heap. Oh, here we can say it is a max heap because we have just one element, that is 10. Now on this free space we have write like 15. We have just put here 15. Now this is the array we are finally get. Now if we are observe carefully, you find that this is sorted array. 10, then 15, then 20, then 30, and maximum is 40. Yes, this is a sorted array. So this is basically the concept of heap sort. Okay, this is the process of heap sort. So this is the process how can we do the heap sort. So I think it is a clear up to you that what is heap sort. Then we are discussing about the Heapify, last thing of the Heapify. Heapify is basically a process for generating a heap tree from a binary tree. We have given a binary tree and we generate a heap by using this process called Heapify. How can you do a Heapify process? Basically just one thing keep in mind. Here we apply the concept of deletion. Okay, what is the process of deletion? We are just adjust the elements on the downwards. Same way we are here also. And we are starting from the right hand side of the array in this Heapify method. Instead of doing the insertion procedure, in the insertion, what is the procedure? We are inserting on the leaf and we are adjust on the upward. And we are starting from the left hand side of the array. But here in this Heapify, in this process, we are do the same concept of the deletion in heap. And we are do the adjustment on the downwards. And we are starting from the right of the array. So now start from the right hand side of the array. What is the right hand side element? 19. So now just assume that there is no element, just only one element, 19. Is this a heap? Yes, this is the only one element. Yes, it's 19. Just we have assume that we have only one node, 19. Yes, it is a heap. Yes, it is a max heap. Okay, this is a max heap. Just only one element. Just consider. Now again, next element. What is the next element? We are go to from the right hand side. Next element 25. Here is a 25. We are assume that there is only one element, that is 25. Yes, there is no child. Yes, this is a max heap. Now go to the next element. What is the next element? 42. Come here. Is there no element? Yes, this is a max heap. Go to the next element, that is 13. Come here. Yes, this is a max heap because consider just we have only one element, that is 13. Yes, this is become the max heap. Have not any child. Now, what is the next element? 16. Next element 16. Okay. Next element. What is the next element? 16. Now again we are coming and check is this part is a now what is the procedure on the deletion? We know adjustment done on the downward. Same way here also we done the adjustment on the downward. That means we are checking is a max heap or not. No, it is not a max heap. What is the procedure of deletion? We know what is the procedure. This is a part. I think I'm talking about this part. Okay. Here we are already checked this is a max zip. All are in the max zip. Okay. But here, if you are checking on the 16, is not a max zip. What is the procedure? Procedure of the deletion says that for making the max zip, we must compare with the two children of the root. That means we will compare with the for 25 and 19. Taking the which is a greater. What is a greater? 25 is greater. So swap with the root of the greater child. So exchange with the 25 and 16. 25 is go here, 16 is goes there. So yes, 25 is go there, 16 is goes here. Again we go again. Now we are again compare. What is the next element? 21. 21 we are already done in the 16. Now 21. Check here. If you are check, is this a max zip? No, it is not a max zip because 21 is smaller. 21 is smaller than the 42, but it is not a done in the max zip. So again we do the same. Adjust on the downward means do the same concept of the deletion. The rule says that if it is not a max zip on the deletion, we must compare with the two children 13 and 42. What is now? Take the greater child, that is 42 is greater. Swap with the root of the greater child. So 42 is goes here, 21 is go there. 42 is goes here, 21 is go there. Now what is the next element? 42 is over. Now next is 10. Next is 10. Now again we compare, check it is a max zip or not. No, it is not a max zip because 20 is smaller than is all these both child 42 and 25. Now same rule we are applied. What is the rule says? The deletion rule says that compare with the two child of the root. Now found which is the greater. Compare with 42 and 25. 42 is greater. Swap with the root of the greater with greater child. 42 is go here, 10 is go there. So 42 is go here, 10 is go there. Now again check. This is a max zip. Now we check if yes 42 is greater than 10 and 25, okay, but here no, 10 is smaller than is all childs. No, it is not a max zip. Again we do the same property of the deletion we have done. What is the rule says? Compare with the two children of the root and pick up the greater child. That means if you compare with the 13 and 21, 21 is greater. Swap with the root of the greater child. 21 is goes here, 10 is go there. Yes, this is our max zip, final max zip. Why? 42 is greater than 21 and 25. 21 is greater than 13 and 10. 25 is greater than 16 and 19. So yes, and 42 become the maximum element which is on the root. This is the property of the max zip. So yes, this is the become a max zip. So this is the procedure of the Heapify for generating a heap tree from a binary tree. So basically in this Heapify process, what is the Heapify process? Basically generating a heap tree from the binary tree. Basically we have done the process of the deletion. We are starting from the rightmost element or right direction of the array, and we are doing adjustment from the downwards. Take the one by one elements, okay, on this array and check is a max zip or not. If it is not a max zip, then follow the rules for the deletion of a node. Same way we are done in the Heapify. And after that, from the processing, we get a max zip from this normal binary tree. This is a normal binary tree, is not a heap. But after the Heapify procedure, we get the max zip. I think it is a clear up to you what is the heap sort and what is the how can you do the Heapify process. Heap is very important. Clear the idea. I think it is clear up to you. Thanks for watching.